Hello and welcome again to the sixth episode of Math Evolutions from Rocks to Robots. Today we will look at the Islamic Golden Age. Today we journey into one of the most vibrant intellectual periods in history, the Islamic Golden Age. Between the 8th and 13th centuries, scholars across the Islamic world not only preserved the knowledge of ancient civilizations but made revolutionary advancements in mathematics, influencing generations to come. As the Islamic Empire expanded, it absorbed the intellectual traditions of early civilizations, Greek, Persian, and Indian. The caliphs, especially in Baghdad, recognized the value of this knowledge and sponsored an unprecedented translation movement. The House of Wisdom in Baghdad, founded in the early 9th century, became a center of translating important works by mathematicians such as Euclid, Ptolemy, and Aryabhatta into Arabic. By preserving and translating these texts, scholars like Hunayn ibn Ishaq and Thabit ibn Qurra ensured that knowledge, which might have been lost in Europe's dark ages, was not only safeguarded but also built upon. One of the most pivotal figures of this era was Al-Khwarizmi, often referred to as father of algebra. In the 9th century, he wrote a book that gave birth to the discipline we now call algebra. His systematic methods for solving linear equations and quadratic equations were groundbreaking. Algebra, or literally meaning the reunion of broken parts, moved beyond the geometric methods of Greeks to a more abstract form of mathematics, which allowed for greater manipulation of numbers and symbols. This was a profound shift in mathematical thinking. Al-Khwarizmi's work didn't stop there. He also introduced the world to a new way of thinking about numbers. His book on arithmetic, based on the Indian numeral system, helped spread the use of Hindu-Arabic numerals, including the concept of zero, across the Islamic world and eventually to Europe. One of the most important developments in the history of mathematics was the introduction of the decimal system and the use of zero, borrowed from the Indian mathematics. Al-Khwarizmi and other scholars popularized this system, which allowed for easier calculations and formed the foundation of modern arithmetic. Before this, European mathematics was using Roman numerals, which was cumbersome for complex calculations. The simplicity and the power of the decimal system transformed mathematics and everyday commerce, providing a much more efficient way to deal with large numbers. Islamic scholars also made crucial contributions to geometry and trigonometry. One of the key figures was Al-Battani, who improved von Ptolemy's work in astronomy and produced accurate tables of sine, cosine, tangent functions. Al-Battani's work was especially valuable for calculating the positions of stars and planets, which had both practical and religious values for determining prayer times and the direction of Mecca. His trigonometric work was essential for future developments in both Islamic and European astronomy. Other prominent mathematicians like Ibn al-Haytham contributed to geometry. His work on optics and geometry laid the groundwork for the later contributions in calculus. He also developed the method of exhaustion, an early form of integration. Omar Khayyam, known to many in the West as a poet, was also an outstanding mathematician. In the 11th century, he made significant advances in solving cubic equations. Although he couldn't find an algebraic solution, he developed the geometric methods that were centuries ahead of their time. Khayyam also contributed to the reform of the Islamic calendar, refining it to be more accurate than the Julian calendar in use in Europe. The knowledge preserved and advanced by Islamic scholars didn't stay in the Islamic world. Starting in the 12th century, texts were translated from Arabic into Latin, helping to ignite the European Renaissance. Scholars like the Fibonacci, who studied in North America, introduced Islamic mathematics to the West, introducing algebra and the decimal system. This exchange of knowledge had a lasting impact. The mathematical discoveries of Islamic Golden Age laid the foundation for modern algebra, geometry, and trigonometry, and ultimately influenced the development of calculus and other advanced fields. The Islamic Golden Age was a time of profound mathematical progress. Through the preservation of ancient knowledge and their own groundbreaking discoveries, scholars of this era set the stage for the development of mathematics as we know it today. from the algebra to trigonometry, their work continues to influence the modern world. Make sure to like, subscribe and turn on those notifications so you get notified whenever we post a new video. And make sure to check out the rest of the series, Math Evolutions from Rocks to Robots.